first problem is just a straightforward application of the formula that we've learned. There is zero initial height, or we could take the initial height to be zero, wherever that is, and we know that the initial velocity is zero. And if we ignore the negative sign, then we'll just look at how this thing kind of moves. We just kind of define the positive direction to be downward, and this will tell us the distance that it falls under the acceleration due to gravity. And if we then set that equal to 100, right, suppose that it falls for 100 meters and solve for the time, then we will have that solution for the second part of the problem. So running the code, we get these two solutions. Next, we want to know what happens if it's thrown with an initial height of 100 meters with a speed of 10 meters per second. So how fast will it be traveling after 10 seconds? So this is a how fast question, right? So all we're doing is using the fact that it had an initial velocity of 10. It has an acceleration of 10 meters per second, and it does so for 10 seconds. So this is really just using the fact that the average acceleration here is delta v over delta t, and using that to solve for the change in velocity, which will be an increase by this much, 100 it turns out. And then we add to it the initial velocity, so that's the total velocity after 10 seconds. The next question asks us how far it will fall in 10 seconds. So there we actually set up the familiar formula with initial height, initial velocity of -10 meters per second, and plugging in the time equal to 10. And that will print out the answer to the next part of the problem. How long must it fall before it is halfway? So we set the formula for motion equal to the halfway point, which is 50, and print out the solution. So there are the answers. So in the next problem, it is thrown upwards with a speed of 10 meters per second. What is the maximum height? So we solve for the time using the vertex formula, and then we plug that into the formula, right? The formula for motion with initial height equal to 0, initial velocity equal to 10, and print that answer. To find out when it hits the ground, we set it equal to 0 and solve. And then we want to know what is the speed that it obtains at that time. So to do that, we take the initial velocity, which is 10, and this time, we think about how it is accelerating downwards. Yeah, it is accelerating downwards at approximately 10 meters per second, multiplied by the time at which it accelerates by that rate, and this will print the answer. Here are all of the answers together, and we're done.